So we're going to quickly review some equations that have fractions in them, and specifically when fractions are coefficients. And just recall that a fraction is a coefficient if it's multiplied in front of a variable. So for example, here 3/7 is in front of the letter m. They didn't write in that multiplication symbol, but that's what it means. Similar, like on this next example, -2/5 y. So we're not going to be dealing with adding or subtracting any fractions today, just multiplying them as a coefficient. So before we actually jump into solving equations with them, the first thing we need to understand fundamentally is that a fractional coefficient actually represents two operations. The numerator represents multiplication, and the denominator represents division. The way that I remember that, denominator, division. So for example, like what does that mean? So let's say we were trying to figure out 1/2 of the number 10, which would be similar to an equation like 1/2 of x. So we're going to use real numbers for a second instead of introducing any variables. So we all know that 1/2 of 10 is 5, but why? Well, because of the operations. Because the top number is 1, that means multiply it by 1, and the denominator is 2, which means divide by 2. So I would start with the number 10 and multiply it by 1, which would give me 10, and then I have to take that answer and divide it by 2. So 10 divided by 2 is 5. Let's try it with something like 3/4 of 36. Oh, let's change that to 3/4 of 12. So what is 3/4 of 12? Well, I know that the top number is what I have to multiply by, and the bottom number is what I divide by. So I'd start with my number 12, and I have to multiply it by 3, which gives me 36. And then I take that answer and perform the denominator, which is divide by 4, which gives me the number 9. Now what's really cool is we can actually do these in any order, right? That's what the order of operations tells us. So over here I started with multiplying by 3 and then dividing it by 4. So maybe I want to start the other way. Maybe I start with 12, divide by 4 first, which would give me 3. Take that 3 and then multiply it by the numerator, which also happens to be a 3, and get 9. Let's do one more quick one of that just for fun. Let's do 3/5 of 25. And again, there's two ways I could do it. I'm going to start with 25. And at first I would multiply by the numerator, which 25 times 3 is 75. And I would divide by the denominator. 75 divided by 5 is 15. Now maybe that's too hard of math to do in my head, so if it's too hard to do it that way, do it the other way. Start with division. 25 divided by 5, well that's 5. Take that answer and multiply by the numerator, which is 3. So that gives me the answer of 15. So again, super important, we see a fraction as two operations, multiplication and division. So the big idea number 2 then that leads us to actually working with equations is if a fraction represents two operations, you should undo each fraction with 2 steps then. Don't try to do it in one. If there's 2 operations, undo each operation. So for example, let's say we have this equation 3/5 x is equal to 12. So we can clearly see we have a fraction as a coefficient in front of x. So we know that when a teacher makes an equation like this, they come up with an answer, then they do a bunch of stuff to it, and then they tell you what they got, so you can undo all their things. So we're going to kind of go through that again down here. If you haven't watched that video from section 1.2 that goes through that, I recommend going back and doing that. But when my teacher was making this equation, they picked a secret number and they called it x. So that's why they wrote this x here. But then they did something to it, because if they just told me what the answer was, that's not really a math question. So they disguised it by performing a bunch of operations. Now, what did they do? Well, this is where a fraction comes in. We know that the top number of a fraction means multiply, and the bottom number means divide. So when I see this x right here, there's 2 things that happen to it if there's a 3/5 in front of it. It gets multiplied by 3, and then the bottom means divide by 5. Now, the reason we want to do that is so we can undo them in 2 different steps. So if they got 12 as an answer, we're going to start with their equation. Now, the last thing they did was divide by 5. So how do I undo dividing by 5? Well, I'm going to multiply both sides by 5. So it's easy to see that 12 times 5, that's obviously 60. Now, on the left side, if it's unclear what I'm supposed to do, the whole reason I multiplied by 5 was to undo the division of 5, so they should undo each other. So I'm left with 3x is equal to 60. That makes sense. If my teacher multiplied by 3, I want to undo that. So to undo multiplying by 3, I would divide both sides by 3. So that gives us x is equal to 20. So if my teacher started with a secret number called x, I should end with that secret number called x. So look at another example. So again, we can see one fraction in front of a variable. What I did throw in here is that this fraction has a negative. And just to help you with negative fractions, I included this little tip over here. We know that when a fraction is negative, like negative 2/5, I could write it as negative 2 over 5 or 2 over negative 5. But I can never write it with a negative on top and the bottom. If I tried to do that, a negative on top and the bottom, the negatives would reduce and it wouldn't be a negative number anymore. So the negative only goes in one place. So what I recommend when you see a negative in front of a fraction, just right away decide where you want it and rewrite it so you know where it is. So for example, I'm just going to put it on top. That's where I chose to do it. So I'm going to rewrite the negative on top. And once I do that, now I'm going to go through the same thought process that I did before. Somebody made an equation here, and in this case, they called their secret number y. So I just like to identify where that is. So there's y. So like, what did they do to it? Well, I can see there was two things. There's the numerator of the fraction, and there's the denominator of the fraction. So the numerator stands for them multiplying. So if the numerator was negative 2, they multiplied by negative 2. Then they went to the denominator, which means divide by 5, because 5 is the denominator. So if that's what they did, I am just going to undo that. So we already know what their answer was. So to undo dividing by 5, I would have to multiply by 5. So the right side, 4 times 5, that's obviously 20. Now on the left side, the whole reason for multiplying by 5 was to undo dividing by 5. So if they're inverses, they should undo each other and go away. So I'd be left with negative 2 times y. So I've undone that step. If my teacher multiplied by negative 2, to undo multiplying by negative 2, I would divide by that negative 2. And of course, the reason we divided by negative 2 was to undo the multiplication, so they should cancel. And I get the answer of y equals negative 10. And again, now that we know what fractions do, we can check our answers way more easily. So if I plug in what I thought was the answer, I should be able to show that it equals 4. So when I see a negative, I'm going to put it on top because that's easier for me to do. And as we started the video with, I know how to multiply the number 10 by a fraction. I'm going to do it in 2 steps. I'm going to first multiply by the numerator, take that answer, and then divide by the denominator. So I can see that by plugging in negative 10, I do get 4. So I started with the correct number, and that was 4. Lastly, one example, what if there is more than just a fraction? It's very similar, but we just have an extra step to undo. So when I first look at this fraction, I can see that there's a negative in front of it. So just like we talked about last time, let's just rewrite it and put it wherever we want to. Since I put it on top last time, I'm going to put it on the bottom this time. And again, it doesn't matter where you put it. You'll get the same answers if you do it correctly. Excuse me. So I'll put the negative with the 4. Now, in this case, we have a plus 6. We just have to remind ourselves of our order of operations. And we have to list the order that the teacher disguised their number using the order of operations. So whoever did this, they picked some secret number and they called it x. So there it is. That was their first step. Now, what did they do to it? Well, I see some things. I see a fraction, which is multiplication and division. And then I also see addition. So according to our order of operations, we need to do that multiplication and division first. So by putting a 3 on top of the fractions, that means they multiplied it by 3. Because there's a negative 4 on the bottom of the fraction right here, that means they divided it by negative 4. Once we took care of the 3 and the negative 4, the last step was they added 6. If you started with the correct secret number and you performed those operations, you should get 12. So it's my job to undo them. So if I started with their answer, I don't want to add 6. I want to undo what they did. So to undo 6, I would subtract 6. Now working backwards, if they divided by negative 4, I want to undo that. So the opposite of dividing is multiplying by that number. And again, the whole reason we multiplied by negative 4 was to cancel the division of negative 4. And then if they multiplied by 3, to undo that, we would divide by 3. So we get x is equal to negative 8. And of course, we should check that. If we plugged in negative 8, so I'm just going to plug it back into the original. Let's see if we get 12. Well, we know to figure this part out, we would take negative 8 and multiply it by 3. Take that result and divide by the denominator, which was negative 4. So that gives us the number 6. So is 6 plus 6 equal to 12? It sure is, so we know we are correct.